Hi students and friends, this is your host and teacher Sayyid Ayazuddin Haider and you're watching Learn and Teach by Sir Ayaz. So I will continue my video session for past papers and this time I have selected 0620 paper 43 of October-November 2023. The time is 1 hour 15 minutes. It's paper 4 theory extended version. You have to answer all the questions. You can use calculator in this paper. The total mark for this paper is 80 and the periodic table is printed in the question paper. So let's start the paper. Here's question number 1. A list of substances is shown. Barium nitrate, carbon monoxide, hydrated cobalt 2 chloride, copper 2 oxide, anhydrous copper 2 sulfate, ethane, potassium iodide, propene, sodium bromide, sulfur dioxide, zinc oxide. Answer the following questions using only the substances from the list. Each substance may be used once, more than once, or not at all. Give the name of the substance that A. gives a lilac color in a flame test. So lilac color in the flame test is for the presence of potassium ion. So we have potassium iodide here. So we'll write potassium iodide. Remember, this flame test is something which you have to learn by heart. You have to learn the ions with their colors. B. Forms of cream precipitate when its aqueous solution reacts with acidified aqueous silver nitrate. The test with silver nitrate is used to identify the source of halide ions, Cl negative, Br negative, and I negative. Cl negative forms white precipitate, Br negative forms cream precipitate, and I negative forms yellow precipitate. So for the cream precipitate, I have to look for the bromide salt, and we have sodium bromide here. So I will write sodium bromide in this case. C is an acidic oxide. If you look at the list, there's only one gas which is responsible for acidic oxide. One gas which acts as an acidic oxide, and that will be sulfur dioxide. Remember, non-metal oxides act as an acidic oxide. There are few exceptions: carbon monoxide, nitrogen monoxide, and water. These are not acidic oxides; these are neutral oxides. So you have to write sulfur dioxide here. D is an unsaturated hydrocarbon. Unsaturated hydrocarbon must contain carbon-carbon double bond. So if you look at the list, we have propene. Propene belongs to alkene, and alkenes are unsaturated. We don't have any other unsaturated organic compound or hydrocarbon here. Alkene is the only hydrocarbon in this list which contains carbon-carbon double bond. And in this case, we have 3 carbon with 1 double bond between 2 carbon atoms. So I will write propene for this one. E is a product of incomplete combustion of fossil fuels. Now, during the combustion reaction, the expected products are unburned carbon, carbon dioxide, carbon monoxide, and steam or water. Now, there are 2 types of combustion reactions. We have complete combustion reaction and incomplete combustion reaction. In case of complete combustion reaction, you will get carbon dioxide and steam or water, while in case of incomplete combustion reaction, we will get carbon monoxide and steam or water. So in the list, they have provided us with carbon monoxide. So I'm going to choose carbon monoxide for this choice. Number F is used to test for the presence of water. If you look at the list, there's anhydrous salt, which is anhydrous copper 2 sulfate. Anhydrous copper 2 sulfate and anhydrous cobalt 2 chloride is used. Can't use cobalt chloride because it's already hydrated. Hydrated means it contains water in it. So anhydrous copper 2 sulfate can be used to check the presence of water because this will react with water to form hydrated salt. So you write copper 2 sulfate, anhydrous copper 2 sulfate, sorry. You have to write the full name, anhydrous copper 2 sulfate. Moving to next question, that's question number 2. Table 2.1 gives information about particles A, B, C, D, E, and F. So here's table 2.1. About these particles, they gave us number of electrons, number of neutrons, and number of protons. A, give the letters of all the particles which are number 1, atoms. So atoms means they are talking about neutral charged particles which contain same number of protons and electrons. So A must be one of these. So you write A because it contains same number of electrons and protons. B is also in the list because it also contains same number of electrons and protons. Look at the number of protons and electrons. And for other, we have F. So A, B, and F must be the final answer for this question. 2. Ions with a charge of 2 minus. 2 minus means it must have 2 extra electrons. So if you look at the C, D, and E, these are ions because they have different number of protons and electrons. Now, in case of D, it has 2 extra electrons, which means that it must be carrying 2 minus charge. So D must be the right answer for part 2. Number 3, cations. So cations, it must be having less electrons than protons. So it must be C. C is the one which contains less electrons and protons. B, state the atomic number of A. So atomic number of A, we have to look for the number of protons here, which is 5. So you'll write 5 here. Part C, determine the number of nucleons in D. Number of nucleons is also known as nucleon number. And when we talk about nucleon number, you have to add protons and neutrons. So they are asking about the total number of protons and neutrons altogether for D. So if you look at D, here is D. The number of neutrons is 17 and number of protons is 16. So you'll add up these 17 plus 16. So I will write 17 plus 16. And if you'll add up these, you'll get 33. This will be the final answer. For part D, state the electronic configuration of D. Electronic configuration, this is distribution of electrons in different shells. Distribution of electrons in different shells. So for D, first of all, we need to know the number of electrons in D. In D, the number of electrons are 18. So 18 is the total number of electrons. For your convenience, I am writing the 18 here on one side of D so that you can easily place the number of electrons in each shell. First shell, the maximum capacity is 2. Now 18 minus 2, 16 electrons are left. So second shell, maximum number 8. So 8 plus 2 is 10. 10 minus 18 will get 8. So this will be the final electronic configuration for D. E, state the group number of F. Now if you look at F, the number of electrons in F is 15. And if you write the electronic configuration of F, it must be 2, 8, 5. 5 means it must be in group 5 because the valence electrons indicates the group number. So you write 5 here. F, state the period number of B. For this, again, we need to know the electronic configuration. B, the number of electrons are 10, which means the electronic configuration must be 2, 8. As you can see, there are 2 shells on it, so it must belongs to period number 2. So I'll write period number 2. Moving to next question, that's question number 3. This question is about nitrogen and some of its compounds. A, nitrogen is converted into ammonia, NH3 in the Haber process. Number 1, nitrogen is obtained from air. State the percentage of nitrogen in clean, dry air. Now, this is something you have to learn by heart. The percentage of nitrogen in air is 78 or 79%. You can write one of these. Number 2, state the source of hydrogen for the Haber process. Now, hydrogen can be obtained from natural gas. And if you recall the old syllabus, so according to the old syllabus, you can also get it through cracking of higher alkanes or long chain alkanes, or cracking long or higher alkanes. Number 3, complete the dot and cross diagram in figure 3.1 for a molecule of ammonia. Show the outer shell electrons only. So nitrogen is attached to 3 hydrogen atoms. You know that the number of electrons in hydrogen is 1. Here is hydrogen. The number of electron must be 1. Here is a proton number. What about nitrogen? The proton number of nitrogen is 7. It's in group 5, which means it must have 5 valence electrons. So for nitrogen and hydrogen, first of all, I'm going to show the valence electrons of hydrogen. These are the valence electrons of hydrogen. 1, 2, 3. Now for nitrogen, 1, 2, 3, 4, 5. This will be the final dot and cross diagram for the ammonia molecule. Number 4, write a chemical equation for the reaction occurring in the Haber process and give the typical reaction conditions. Include units where appropriate. Now the chemical reaction is the reaction between nitrogen and hydrogen. So we have 1 mole of nitrogen reacting with 3 moles of hydrogen to produce 2 moles of ammonia. There must be reversible sign. It's a reversible reaction. So final product will be 2NH3. Now the reaction conditions, temperature 450 degrees centigrade. Pressure, it's either 200 atm or 20,000 kPa, kilopascal. Catalyst used here is iron. You can even write the symbol of iron. Now part B. Ammonia is converted into nitric acid. The first stage of this conversion uses a catalyst and occurs at a temperature of 900 degrees centigrade and a pressure of 5 atmospheres. Here's the reaction: 4NH3 gas plus 5O2 gas, reversible sign, 4NO gas plus 6H2O gas. The forward reaction is exothermic. Number 1, suggest which of the following elements is most likely to be used as a catalyst. Draw a circle around your answer. So you know that if you look at the periodic table, so here we have elements that are also known as transition elements. They are used as catalyst. Transition. They have one typical characteristic that is they can be used as a catalyst. Transition elements or their compounds can be used as catalysts. So you can't choose the elements from other groups. You have elements from other groups like calcium belongs to group 2. It can't be used as a catalyst here. Lead belongs to group 4. So it can't be used as a catalyst here. Platinum. This belongs to transition element. Here's platinum. So platinum can be used. So I will circle around platinum. What about the others? Sodium, it's in group 1. It can't be used as sulfur. Group 6, it can't also be used as a catalyst. Can't use sulfur as a catalyst. Continue. This moving to next question. Part 2. State the oxidation number of nitrogen in NH3NO. So in case of NH3, nitrogen is attached to less electronegative hydrogen. Hydrogen, whenever it's attached to non-metals, it will carry +1 as its oxidation number. So I'm going to show the working here. So for NH3, I need to find the oxidation number of nitrogen. I will take X plus 3 atoms of hydrogen. It must be carrying +1 charge. +1 as its oxidation number. The overall charge is 0. So I will write 0 here. So X plus 3 is equal to 0 or X is equal to -3. So it must be carrying -3 here. What about the oxidation number of nitrogen in NO? Look at the position of nitrogen and oxygen. Here is nitrogen and oxygen is more electronegative. O is more electronegative than nitrogen, which means it will carry minus charge. And oxygen is in group 6. Group 6 carries -2 or 2 minus charge. So if oxygen is carrying -2 charge, nitrogen must be carrying +2 charge. For nitrogen, I will take X. Oxygen, here's one atom of oxygen, so I will write -2 is equal to 0. So you will get +2. So +2 will be the oxidation number of nitrogen in NO. Number 3, use your answer to explain whether the nitrogen in ammonia undergoes oxidation or reduction. Now it's converting from NH3 to NO. If you look at the oxidation numbers, it's changing from -3 to +2, which means it's undergoing oxidation. So I will write oxidation here. Then I have to explain. So oxidation number here, it's increased. So I will write oxidation number increases. Moving to part 4, complete table 3.1 using the words increases, decreases, or no change. Decreasing the pressure, what will be the effect on the equilibrium yield of NO? Where is NO? It's on the product side. If you decrease the pressure, the equilibrium will shift to the side where there will be higher number of moles of gases, moles of volume of gases. So if you add up these 4 plus 5, you will get 9 moles on the reactant side. And on the product side, 4 plus 6, it will be 10 moles, which means decreasing the pressure will shift to the right hand side and there will be increase in the yield of NO. So I will write increases. Effect on the rate of the forward reaction. What will be the effect on the rate of forward reaction? Not decreasing the pressure, it decreases the rate of the forward reaction. So you'll write decreases. Because if you decrease the pressure, the distance between the gas particle it will increases and they will take more time to collide with each other. So the rate will definitely decrease. Decreasing the temperature, effect on the equilibrium yield of NO. For this, you need to know the type of reaction in terms of change in energy. That's whether it's exothermic or endothermic. The forward reaction is exothermic, which means in the forward direction you have delta H minus, and the backside direction, that's on the reactant side, should be positive because endothermic. So forward direction favors low temperature. So low temperature increases the yield of NO. So decreasing the temperature increases the yield of NO. So I will write increases. Removing the catalyst. Now catalyst, they have no effect on the equilibrium yield of NO because catalyst simply increases the rate of reaction in both directions. Rate of reaction in both direction. It doesn't have any effect on the concentration or yield of the reactant or product. So we'll write no change here. Part F, sorry, 5. Decreasing the temperature causes the rate of the forward reaction to decrease. Explain using collision theory why the rate of the reaction is slower at the decreased temperature. Now, definitely this decreases the kinetic energy. So you write kinetic energy of particle is lower. Kinetic energy of particles decreases. That's why the rate of reaction decreases. Now, this will also decrease the frequency of collision. Frequency of collision between particles decreases. Now here less proportion or less number of particles have energy equal to or greater than activation energy. Fewer or less proportion of particles have energy equal to or higher than activation energy. Part C. In the second stage, nitric acid is produced. Balance the symbol equation for this reaction. This reaction between NOO2 and H2O to produce HNO3. So if I will take 2 moles of NO, then I have to place, if I will take 2 moles before NO, then I have to place 2 before HNO3. This makes oxygen 6 and hydrogen 2. So can we balance oxygen on the left hand side? No, we can't balance it because there will be 6 number of oxygens on the left hand side. It will be better if you write column like this: reactants, products. We have same elements on both sides. We have nitrogen, oxygen, and hydrogen. Let's write the number of atoms of these. We have 1 on the reactant side and 1 on the product side. Oxygen, we have 2, 3, 4, 4 on the reactant side, and on the product side we have 3. What about hydrogen? 2 on the reactant side and 1 on the product side. So we need to balance both oxygen and hydrogen. So what if I will place 2 on the right hand side, so the nitrogen will become, if we place 2 before NO and 2 before HNO3, we'll have 2 moles of N. Oxygen on the reactant side becomes 2 plus 2 plus 1, 5. On the product side will become 2 multiplied by 3, 6. What about hydrogen? It will be balanced. There will be 2 moles of hydrogen on the product side. Now, if you will take 3, before NO, we need to place 3 before HNO3. So we'll have 3 nitrogen on both sides. What about oxygen? 3 plus 2 plus 1, 6. 6 oxygen. On the product side, 3 3s are 9. Hydrogen, it becomes unbalanced. So you can't take 3. Let's try 4. If I will place 4 before NO and 4 before HNO3, N becomes 4 on both sides. What about oxygen? 4 plus 2 plus 1, 4, 5, 6, 7. And on the product side, 4 3s are 12. Leave oxygen now. Check hydrogen. If I will place 2 before H2O, hydrogen is balanced. 4 on the reactant side, 4 on the product. Yes, hydrogen is balanced. Now we need to balance oxygen. This time I think we can easily balance oxygen now. All the other atoms are balanced. 4 multiplied by 3 is 12. So we need to have 12 moles of oxygen on the reactant side. So 4 plus 2 is 6. 6 minus 12 is 6. So if you place 3 before O2, this will be the final balanced equation. This is the final balanced equation. Moving to next question. Number 4. This question is about sulfuric acid and salts that are made from sulfuric acid. A. Zinc reacts with dilute sulfuric acid. Aqueous zinc sulfate is one of the products. Powdered zinc is added to dilute sulfuric acid. The mixture is stirred. Stirred means mixed. More zinc is added with stirring until the zinc is in excess. Here's the reaction equation. ZnS plus H2SO4 gives ZnSO4 plus H2G. The mixture is then filtered. 1. Name the limiting reactant. If you look at the statement, in this statement, they have mentioned that zinc is in excess. So it must be dilute sulfuric acid. That's the limiting reactant in this. So you write dilute sulfuric acid. Number 2, state 2 observations that indicate that zinc is in excess. So 2 observation, one of the observation must be no more solid dissolves. So this is the reaction between metal and acid. The gas is produced, we see the bubbles, there will be no bubbling. The bubbling stops. So you'll write, first of all, you write no more solid dissolves. No more solid dissolves. And the next point must be bubbling stops. Bubbling stops, or even you can write ceases. Ceases and stop, they have same meaning. Number 3, name the filtrate. Filtrate must be the aqueous solution of zinc sulfate. You write aqueous zinc sulfate. Aqueous zinc sulfate. Because filtrate is the one which passes through the filter paper and it contains a soluble salt. Number 4, name 2 compounds which both react with dilute sulfuric acid to produce aqueous zinc sulfate. You can take any one of these, any 2 of these, any 2 from, you can take zinc oxide, zinc hydroxide, or zinc carbonate. Zinc oxide or zinc hydroxide or zinc sulfate. Moving to next question, that's part B. Zinc sulfate crystals are produced by heating aqueous zinc sulfate until a saturated solution is formed. When the saturated solution cools down, crystals of zinc sulfate start to form. Number 1, state what is meant by the term saturated solution. The solution that can hold the solution that cannot hold or dissolve any more solute particles at given temperature. Solution that cannot dissolve or hold more solute particles at a given temperature. You have to mention this point, at a given temperature, because saturated solution is obtained at specific temperature. Number 2, explain why crystals form when the saturated solution cools down. The solubility decreases as temperature decreases. Solubility decreases as temperature decreases. C. Nickel 2 sulfate crystals contain water of crystallization. When nickel 2 sulfate crystals NiSO4.XH2O are heated, they give off water. Here's the reaction. NiSO4.XH2S gives NiSO4S plus XH2OG. A student carries out an experiment to determine the value of X in NiSO4.XH2O. Step number 1. Nickel 2 sulfate crystals are weighed. Step number 2. Nickel 2 sulfate crystals are heated. Step 3. The remaining solid is allowed to cool and is then weighed. Step 4. The remaining solid is heated again, allowed to cool and is then weighed. Step 5. Step 4 is repeated until there is no change in mass. Number 1. State the term used to describe crystals that contain water of crystallization. So hydrated is a term that is used for this. So you write hydrated. Part 2. State why step 4 is repeated until there is no change in mass to ensure all the water of crystallization is removed. To ensure that all the water of crystallization is removed. Number 3, in an experiment, 0.454 gram of nickel 2 sulfate crystals NiSO4.XH2O is used. The mass of anhydrous nickel 2 sulfate NiSO4 remaining is 0.310 gram. MR of H2O and NiSO4 is given. Determine the value of X in NiSO4.XH2O. Use the following steps. Calculate the number of moles of NiSO4 remaining. So we need to calculate the number of moles of NiSO4. So you need to divide the mass of NiSO4 by its MR. MR of NiSO4 is given. So first of all, we need to find the mass of NiSO4. Anhydrous NiSO4, it is 0.310. So you'll divide 0.310 by MR, that is 155. 0.31 divided by 155 and 0.002 moles. This will be the answer. So I will write 0.002. Calculate the mass of H2O given off. So first of all, I need to find the mass of H2O here. That's what they are saying. So you'll subtract the anhydrous nickel 2 sulfate, the mass of anhydrous nickel 2 sulfate from the mass of hydrated nickel 2 sulfate crystals. So 0.454 minus 0.310. 0.454 minus 0.310. 0.144. This will be the mass of H2O. Calculate the number of moles of H2O given off. MR of H2O is also given. So you'll divide the moles by MR. 0.144 divided by 18. 0.144 divided by 18. 0.008. These are the moles of H2O. Calculate the value of X. So we have moles of anhydrous crystals moles of water, which is 0.002 and 0.008. 0.002 moles reacted with 0.008 moles of water. Therefore, 1 mole contain X. So you write X is equal to 0.008 divided by 0.002. It's very simple, but for your convenience, I'm doing this. The answer must be 4. So the answer is 4 here. The value of X is 4. Moving to next question. Number 5. This question is about iron. A1. Describe the bonding in a metallic element such as iron. You may include a label diagram as part of your answer. Now, I recommend students to show at least 3 layers when you are drawing the diagram for metallic bonding. So we have layer number 1. Put positive inside each circle. Here is layer number 1, layer number 2, and layer number 3. Then we have electrons. These are the iron cations. Iron cations. Now, free moving electrons, I am using dash line with red. And these are the mobile or delocalized electrons. Mobile, delocalized electrons. Now they are saying you have to describe, and it's of 3 marks. So you have to mention few things here. You have to mention the force present, which is strong electrostatic force. So 1 mark for this. Strong electrostatic force. Between the other mark for metal cations. Metal cations. And the third mark, and C of mobile or delocalized electrons. C of delocalized electrons. In this way, you'll get all 3 marks. Part 2. Explain why iron conducts electricity when it is solid. It must be having free electrons, or electrons can move. Electrons are mobile or can move. Moving to next part, B. Iron is extracted from hematite in the blast furnace as shown in figure 5.2. Here's figure 5.2. Look at this figure. We have coke, hematite, limestone on top. Below we have air, slag, and molten iron. Number 1, give 2 reasons why coke is added to the blast furnace. Now, coke is used to reduce iron 3 oxide, or it reacts with carbon dioxide to form carbon monoxide, that is CO. It's also responsible for releasing heat. So you can write any 2 from these, any 2. Like reduces iron 3 oxide, reacts with CO2 to give CO, carbon monoxide, or to release heat. Number 2, Explain how limestone removes the impurities in the hematite. Now, limestone, it decomposes to form calcium oxide, which reacts or neutralizes silicon 4 oxide or SiO2 to produce slag or calcium silicate. So, first of all, you write limestone decomposes to give calcium oxide. Calcium oxide neutralizes or reacts with silicon 4 oxide to form slag or calcium silicate. Part 3. Hematite contains iron 3 oxide. Write a simple equation for the conversion of iron 3 oxide to iron in the blast furnace. So it must be reacting with the reducing agent. So you can either have carbon monoxide or carbon as reducing agent. So if you want to write a reaction with carbon monoxide, the reaction must be Fe2O3 plus CO3CO, and you will get 2Fe plus 3CO2. Or if you are reacting it with carbon, Fe2O3 plus, again you have 3 moles of carbon, you get 2Fe plus 3CO. You can write any one of these. Number 4, suggest why the iron produced in the blast furnace is molten. So temperature in the furnace is above the melting point of iron. Temperature in the furnace is above melting point of iron. Moving to next question. See, most iron is converted into steel. Steel is an alloy. Steel is more useful than pure iron because it is harder and stronger. Explain why the structure of alloys causes them to be harder and stronger than pure metals. You may include a diagram as part of your answer. So you have different size atoms here, which prevents small size atoms to slip or slide over one another. So you can write large size atoms prevent small atoms from sliding over one another. As they are saying, you can include the diagram in your answer. So you have one big size atom like this, big size, and then you have lots of small size metal atoms like this. D. Iron forms rust. Rusting is prevented by coating iron with zinc. Number 1, name the substances that react with iron to form rust. It's oxygen and water. So you write oxygen, and both water and oxygen is important. You can't only write water or oxygen. You have to write both of these. Number 2, name the process in which zinc is used to coat iron to prevent rusting. Now, so technically, the process used is known as galvanizing. Galvanizing. Number 3, explain how the coating of zinc prevents rusting if the zinc is not scratched. So it acts as a barrier which prevents oxygen and water reaching the iron or coming in contact with the iron. So act as a barrier. You'll write act as a barrier. Which prevents oxygen and water to come in contact. Or reaching iron. Number 4, when zinc is scratched, the iron becomes exposed. Explain how the zinc continues to prevent rusting. So definitely zinc oxidizes in preference to iron. So zinc loses electrons. So first of all, you like to refer to the position of zinc. Zinc is more reactive than iron. Zinc loses electrons or oxidizes. You can even form zinc forms positive ions. 6a, esters are members of a homologous series of organic compounds. Give 2 characteristics that are the same for all the members of homologous series. So for the characteristics of homologous series, you can write any one of these. They have same chemical properties, same method of preparation, same general formula, same functional group. Any two from any two. Same general formula. Same chemical properties. Same method of preparation. You can even mention the functional group here. Same functional group. Part B. Ester X has the structure shown in figure 6.1. Name ester X. So there are 2 parts for this. This must be the alkyl group. So there are 2 carbon atoms. It must be ethyl. So I'll write ethyl here first. Second part, we have 3 carbon atoms. So it must be alkanoate, propanoate here. So ethyl propanoate. C1 ester Y has a structural formula HCOO CH2 CH2 CH3. Name the alcohol and the carboxylic acid used to make ester Y. So for the alcoholic part, we cut down this part. This is the alkyl group. We have 3 carbon atoms. So it must be propane 1-ol. So you write propane 1-ol for alcohol. What about the carboxylic group? It's containing only 1 carbon. So it must be methanoic acid. So you write methanoic acid here. Number 2, state the molecular formula of ester Y. So the molecular formula of ester Y, how many carbon atoms? We have 1, 2, 3, 4. C4, hydrogen. 1 plus 2, 3. 3 plus 2, 5. 5 plus 3, 8. H8, oxygen, O2. C4H8O2. Ester Z has the molecular formula C4H8O2. State the empirical formula of ester Z. So simplify this. So 2 is the smallest number. So all these will be divided by 2. 4 divided by 2. H8 divided by 2. O2 divided by 2. So we'll get C2H4O. Party. Polymers containing ester linkages are known as polyesters. Polyamides are another type of polymer. Nylon is a polyamide. The structure of nylon is shown in figure 6.2. Number 1, state the term used to describe the type of polymerization used to produce polyesters and polyamides. It's condensation. Condensation, polymerization. So I will write condensation here. It involves the release of a simple molecule like water or hydrogen chloride. Number 2, complete figure 6.3 to show the structures of the monomers used to produce nylon. Show all of the atoms and all of the bonds. So let's cut down the monomers. So I will write here CO. It must be having OH here. The other option, this can also be the right option for this one. Acyl chloride. This can also be the correct option. What about second part? Must have 2 hydrogen with attached with nitrogen. This must be the final structures of the monomers. F, naturally occurring polyamides are found in food. Number 1, state the name given to naturally occurring polyamides. These are proteins. Last part, F2, name the types of monomers which forms naturally occurring polyamides. Some amino acids. So you write amino acids. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.